Today we're going to be learning about how to find trig functions of any angle, because so far we've only been doing acute angles. And we are going to learn some things that will help us fill in the rest of our unit circle. So let's start with identifying each of our quadrants. And we'll start with quadrant 1. That means the angle would be between 0 and 90 degrees. And this would be theta. And we know this is our x. We put 0 degrees. And this is our y-axis. So this is x. This is y. And we call our hypotenuse, which is the same thing as the radius of our circle, r. And this point that's on the terminal side, remember terminal means end, is x comma y. And so that's if theta lies in quadrant 1. If theta lies in quadrant 2, which means this angle is going to be bigger than 90. And now this is r, this is x, and this is y. And then here's the point right here, x comma y. And if you notice in this quadrant, my x's are negative and my y's are positive. And then if theta lies in quadrant 3, that means we'll start here and go all the way around. Here's r. My x's are still negative, but now my y's are negative as well. And then last, let me pick a different color. If theta lies in quadrant 4, we'll go all the way around. Here's my right angle. Now here's r. And if you notice here, my x's are positive, and now my y values are negative. And then this will be my point right here, x, y. Over here, this will be my point. Remember, both x and y were negative. And in quadrant 4, only the y's are negative. That's going to be very important when we fill in our unit circle. Now, the good thing is we can use this to help us set up our ratio for the 6 trig functions. So if you have a point, which they'll probably call P, x comma y, and the point is on the terminal side of theta, then you can find r, which remember was the hypotenuse, by basically doing x squared plus y squared and taking the square root. Because remember, that's like the Pythagorean theorem. So over here, remember how you had a squared plus b squared equals c squared, and we would square both sides? Well, that's the same thing, but we're using x and y, which represents on the coordinate plane the x coordinates and the y coordinates. So these are the trig functions to help you. So we have sine of theta, which is y over r, cosine of theta, which is x over r. Remember, this is the same thing as opposite over hypotenuse. This is adjacent over hypotenuse. And lastly, we have tangent of theta. Let me use the same colors. Which will be y over x, which is opposite over adjacent. So in the triangle, so you can see what's going on. This is x, which is adjacent, y is opposite, and r represents your hypotenuse, or the radius of your circle. And then we have our reciprocals. Cosecant, reciprocal of sine. Secant, reciprocal of cosine. Cotangent, reciprocal of tangent. Okay? So let's try a problem. Okay, it says let p equals negative 12.5 be a point on the terminal side of theta. Find all 6 trig functions of theta. And if you notice, this is x and this is y. If you notice that x is negative, so we have to think about which quadrant is x negative and y positive. Well, that would be quadrant 2, which means this angle, theta, would be in its terminal side will end up in quadrant 2. So my x, or this point here, is negative 12.5. So we have x and y, we're missing r. So we use that formula, negative 12 squared plus 5 squared. So we're going to get 144 plus 25, which equals 169, which will be 13. So sometimes they'll come out nicely. So we have r, we have x, and we have y. So now we can find our trig functions. You can still use the principle of Pythagorean theorem and using SOHCAHTOA if that will help. Or you can use what we just learned. We know that sine is y over r. And I'll just label this negative 12.5. Because that's, sometimes that'll help. So y is 5 over r. Cosine, remember, is x over r. And then we have tangent, which is y over x. And remember, if we have sine, cosine, and tangent, we have their reciprocal functions as well. So these 3 would be the reciprocals. R over y, r over x, and x over y. And there are your 6 trig functions. Okay, you can try this one. P is the point, negative 3, negative 5, and it's on the terminal side of theta. And I want you to find each of the 6 trig functions of theta. So pause the video and try it. Okay, checking our answers. I first found r, which was x squared plus y squared, and I got the square root of 34. Since it's not a perfect square, we're going to leave it, and we'll rationalize our fractions or our denominators later. So if you notice, I have sine of theta is y over r, cosine of theta is x over r, and both of those needed to had denominators that needed to be rationalized. Then I had tangent of theta, which is y over x, and that came out to be 5/3. And then, of course, once we find our three main trig functions, we know we can find the reciprocals, cosecant, secant, and cotangent by finding the reciprocals of our answers. And remember, when I do reciprocals, I always use the original one because that makes it easier to do the reciprocal without rationalizing. Okay, now we have our quadrant angles. So those are the angles that actually fall on the quadrants on our unit circle. So here's 0 degrees, 90 degrees, which is pi over 2, 180, which is pi, 270, which is 3 pi over 2, and then we also have zero as our radius. And so quadrant angles meaning that they fall on the quadrant. Now since this is a unit circle, you can think of our point P as being 1 unit away from our origin. So since it's 1 unit away, this point would be 1, 0. This one would be 0, 1. This one would be -1, 0. But let me write it correctly. And this point is 0, -1. So if we had to find our quadrant angles, the trig functions, we can start with 0. Remember, this is x, this is y. So when we're finding it, let's start with sine of 0. And that's y over r. And we know that y is 0 and our radius is 1. So 0 over 1 is 0. Cosine of 0 will be x over r. And x now is 1. R is 1. So 1 divided by 1 is 1. And then tangent of 0 will be y over x. 0 over 1, which equals 0. And then I'm just going to go around the circle and do the other quadrant angles. So then we have here for pi over 2 or 90. This is x and this is y. So I'll do sine of 90 or pi over 2 would be y, which now y is 1 over 1, which is 1. Cosine is x over r, which is 0. And then tangent of 90, or pi over 2, would be y over x. And look, we can't divide by 0. So tangent of 90, or pi over 2, is undefined. So we cannot divide by 0. And then I'm going to go over here to pi. And we have sine of 180, or pi, would be y over r, which is 0. Cosine of 180, or pi, would be x over r, which is negative 1. Oh, let me label these for you. And then we have tangent of 180, or pi, which will be y over x. And now this one is 0. So it's okay to do tangent of pi. We can't do tangent of pi over 2. And then our last one is 270, or 3 pi over 2. Y over r, that's negative 1. Cosine of 270, or 3 pi over 2, is x over r, which is 0. And then we have tangent of 270, or 3 pi over 2, is y over x. And up, we can't do it, so it's undefined. And those are our quadrant angles. And of course, we can find the reciprocals now that we have sine, cosine, and tangent for all the quadrant angles. We can go back and do the reciprocals as well. Now, in each quadrant, if you notice, the signs of our trig functions are different. And we have this acronym to help us remember. A SMART trig class. Or some people say all students take calculus. And remember, we always go counterclockwise. And this is quadrants 1, 2, 3, 4. So what this means is, in this quadrant, all the trig functions are positive. In this quadrant, only sine and its reciprocal, which is cosecant, is positive. In this quadrant, tangent and cotangent are positive. And in this quadrant, it's only cosine and secant are positive. Because it's better to remember what's positive than trying to remember everything that's negative. So they're going to give you information. They're going to ask you to name the quadrant. So for example, let me put over here. If I say, name the quadrant where tangent of theta is negative, that means it's less than 0, and cosine of theta is positive. So you look over here, tangent is negative and cosine is positive. The only quadrant where both of those meets those conditions is quadrant 4. Okay? All right, you try this one. Name the quadrant where sine of theta is negative and cosine of theta is negative. I'm going to give you a few minutes tell me which quadrant where both sine and cosine are negative. Okay, if you guess right, then you would have guessed quadrant 3. Because that quadrant, only tangent and cotangent are positive. Everything else is negative. Okay, our last concept in this section is evaluating trig functions. So they're going to give you some information, such as tangent of theta equals negative 2 over 3, and cosine of theta is positive. And they're going to ask you to find, and they're going to tell you which trig functions they want. In this example, we're going to find cosine theta and cosecant. And it can change in what they ask for. But they're giving you this information so that you'll know which quadrant we're in. So we know that tangent is negative, cosine is positive. The only quadrant, and what I do is when I write it, I do A, S, T, C. The only quadrant where tangent is negative, cosine is positive would be quadrant 4. And then we know that tangent is y over x. So that means that this point lies in this quadrant, and x, we know in this quadrant that x's are positive and the y's are negative. So this is x, this is y. So in order to find trig functions, remember we need an x, a y, and a r. So we're missing r. So we're going to have to find r using this formula. X squared plus y squared. So that'll be 9 plus 4, which equals the square root of 13. So now we have x, y, and r. And so we can find cosine. Remember, cosine of theta is x over r. Well, we have x is 3. R is square root of 13. Rationalize in the denominator. We get 3 radical 13 over 13. They also want us to find cosecant. Well, we know cosecant is the reciprocal of sine. So that'll be r over y. R was the square root of 13. But y is negative 2. So that's cosecant. Okay, now I want you to try one. Okay, try this one. Given tangent of theta equals, let's make this negative 1/3. And cosine of theta is also negative. Find sine of theta and secant of theta. So pause the video and try it, and then we'll check our answers. Okay, so if you did it right, first I always have to identify where the point lies. And so I know tangent is y over x. I set up the information they gave me, 1 over negative 3. And I knew it was negative because it said that tangent was negative and cosine was negative, which puts us in quadrant 2. So in quadrant 2, the x's are negative and the y's are positive. So that's how I knew that the negative went with 3. And then I used my formula to help me find r, and I got square root of 10. And then I knew that sine's ratio is y over r. And I know that I have to rationalize the denominator, and that's how I got this answer. And then secant is the reciprocal of cosine. And so that's r over x. And there is your ratio for that. Now remember, if you don't have to memorize the x, the y, and the r, the ratios, you can draw the triangle. But it's very important that you know which quadrant you're in. So like if you wanted to draw this triangle, this would be theta, and then y is 1, and my x is negative 3. I mean, you know that the sides are not negative, so But to help you get a visual of what's going on so you can see, it's negative because it's in that quadrant. And so that way, and here's our hypotenuse, when you're setting it up, you'll know y over r. You'll understand what that means. Or x over r, looking at it from a triangle. So you don't have to memorize the ratios. You just have to know that sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, and tangent is opposite over adjacent. And that concludes our lesson.